Today we're going to cover the process of how scripting works. Really what I mean by that is the cycle of creating a script, being able to have it be executed on the command line, in this case passing in an argument, and really just how all of that works. It's difficult when that's a black box for people. If you type a command, how does the operating system know how to find that command? And then if you do execute a file, how does the operating system know what do I execute that with? Is it a Python script? Is it a Perl script? Is it a Bash script? Is it a compiled tool? Things like that. This is something that comes up a lot with my students, so I wanted to create this video to sort of show that process. Here I'm starting out with a directory in my home area just called tutorials, and in it I've placed a single file that is a FASTA file. For people unfamiliar with that, this is in the field of biology. It's just a plain text file where each entry starts with a greater than symbol, and then the rest of that line can have an identifier, a title, and then all subsequent lines until the next greater than symbol are, in this case, protein residues. Here's, in this case, greater than sign, identifier line, and then this could be DNA, in this case it's protein sequence, until the next entry. And these files can be large. So this particular one has almost 25,000 lines in it. So it's not always quick and easy to be able to know how many entries are in this file, how many protein sequences individually are in this file. So we're going to create a utility to do that. If I wanted it to be called, let's say, count FASTA. If I just try to run that, that command does not exist yet because we're going to create it. So to start, you can use any code editor, VI or Emacs or any of the graphical ones, or just any plain text editor will work. For this, I'm going to use Emacs. So if I say Emacs and then the name of the script that I want, in this case count FASTA, that file doesn't exist yet. It's going to create it. I'm going to put an and sign at the end so that it runs in the background, and that opens my editor. I'm going to scoot it to the side so we can see both the terminal and the script at the same time. I'll also modify it for this tutorial to excuse me, to make the font a little bit bigger so you can see it. There we go. So the important part here is right now, if I flip back to my terminal, the file doesn't exist yet. So I've said Emacs, and I've given it the title, but until I actually save something, the file won't exist on the file system. All scripts, this isn't a Python tutorial, but I'll cover a little bit of it here. All scripts, whether it be Perl or other languages, begin with what's known as a shebang line. So this first line starts with the pound sign, which is often seen as a comment to scripting languages. But the operating system checks this line to see what to run it with. So if I do this, user bin env python 3, that will tell the operating system to look in the environment and find python 3. I could do a full path here. I could say user bin python 3 directly. But it's bad to distribute your scripts that way, because if a user doesn't have Python 3 in that directory on their machine, then the script wouldn't execute because it would say that it can't find Python 3. That's why we do env Python 3, because that leaves it up to the user's environment to find Python 3 and execute the script with that. Now, so I've typed in here, notice if I list on the terminal, the script still doesn't exist. I have to save before that script will exist. So in Emacs, I do Control-X-S. Notice on the bottom it said wrote FASTA. Now if I do an ls, the script is there. Count FASTA appears. That's the cycle we have to go through as we do this. You can type all you want in your editor. It won't actually be on the file system until you save it. So if you are typing and editing code and then you try to run it, it may not run what you've typed most recently unless you do the saving process. In VI, if you're using VI, that's hitting escape and then semicolon and then W. That process writes it to disk, and then you can flick to another terminal and test it. But that process cycles over and over again. You type some, you save, you go to your terminal, and you try to run it. So let's try a little bit. I'm going to write this a little bit quickly because, again, we're not talking about Python really here. This is any script that you're writing. But I want to be able to pass on the command line the FASTA file that I want it to count entries within. So I want to be able to run it like this. Count FASTA, and then pass the name of the script that I want. That lets me be able to use this script on any file that I want to. That, of course, won't work right now. It'll say permission denied. So let's check that first. So import sys. Notice I'm getting no coloring or anything like that in Emacs. That's because by default, I'm going to save and close real fast so you can see. If I had named this script countFasta, if I had named it countFasta.py, like a Python extension, and then edited it, Emacs will automatically be able to tell, and it will give me coloring based on Python mode. Again, I'll make it larger. We'll rename it in a little bit when we're done. Okay. So I'm importing sys. That lets me take, one of the things in that module lets me take arguments from the command line. So the file path is sys. The first argument, argv. Then I'm going to create a counter and start it to be 0. So FASTA, I'll do records found is equal to 0. And then for line in open file path. This will read the file and give me one line each. In this case, if line starts with greater than symbol, then let's increment records found by 1. Now, when that looping is done, I need to actually print something so that I can see the results. FASTA records found. There. So this again imports the sys library so that I can take an argument, initialize the counter to be 0, a loop through each line of the file. If it starts with a greater than symbol, increment the counter, and then when you're done looping, print the results. So I've hit Control XS again, just that way I can save it. Here I'll type clear to give me a fresh terminal. So right now, how do I run the script that I have? If I do a long listing, I see that the script exists. It has content. It was written very recently. But to execute it, if I say count fasta.py, command not found, even though it's right there, it's in the directory that I'm in. That's because the terminal does not search your entire computer for any command that you enter. That would take a very long time, even if it's the current directory. What it does is it searches all directories that are in a special variable, and you can see that by saying echo path, $path. The path environmental variable is the list of directories your computer will search if you enter a command. So here, opt-bin, home, my directory, home jorvis, user local sbin. There's a whole long series of paths that it will search if you type a command without giving the path. And my current directory was not one of them, so it didn't find it. If, on the other hand, I say /count fasta.py, that no longer is leaving it up to the shell to find it. I'm telling it it's here. / means in this directory, run count fasta.py. And of course it fails, it says permissions denied. And that's because the permissions on the script, I never made this script executable. So here it's readable and writable by me, but not executable. So if I do chmod plus x, count fasta, and now do a long listing, I'll see that it is executable. Most terminals will also make it bold, so it changes the color a little bit so that you can see it. Now if I execute count fasta, it will run. Oh, yeah. So, list index out of range. I tried to say argv, get the first argument, run the script, but I didn't pass an argument, so it failed. So I just hit the up arrow to run my last command. Remember, you can cycle through your previous commands by hitting up and down. So I hit up, and then let's copy the name of our file. Now I'm passing it the file name as an argument of what to run. And then it tells me, FASTA records found, 4126. So it's very fast. Even on fairly large files, this will run pretty quickly. But this revision cycle is important to get. So if I go up here, and I don't want it to print all of this, I only want it to print the number, I can get rid of this and have it just print the number. But here if I don't save, I have not saved yet, and I go back to the terminal, it's important to realize since I did not write that to the disk yet, if I run the script again, it's still going to print the words in it. Because on disk, the only thing Python can see is the one that I've written to disk, and it still has that message in it. I have to go here and save first. Now whenever I do it, it's now changed. So it only gives me this. That's something that sometimes students miss, that save process is critical in terms of being able to see your changes. Okay, next. I wanted to be able to do this by just typing count FASTA. I don't want to use this. I don't want to say .py. I just want us to be able to type count FASTA. So there's a few things we can do. First, I'll rename it. Here, let's clear so you can see a fresh screen. I'll rename it, move count FASTA.py to just count FASTA. Now it still works the same. So file extensions in Windows matter because the file extension in Windows is how the operating system knows what to execute it with. So it knows .py would be a Python script. But remember, in Linux, it looks at the first line. So the first line here tells it what to do. You can also call it directly if you know what you want it to run the script with. I could say Python 3 and then the name of the script, and it would run it. It would still work too, but in this case, I'm not actually executing my script at all. I'm executing Python, and then I'm telling Python, read this file, and then pass this argument, which is a different thing. So there's lots of different ways to run the same thing, but this way lets you control how you run it with. Maybe I know that I have a very specific version of Python I want to use, in opt Python 3, then Python 3, and I want to use that version of Python to run the script. I can do that too, just the same way, like this. And it would also work. So there's the flexibility. It lets you can either encode what executes the script in the shebang line, or you can call it directly on the command line. So it's very flexible. So now if I do this, I still have to say still can't do count FASTA, even though that's the name of the script. And remember, it's because count FASTA, this directory that I'm in right now is not in my path. So I can do two things. I can modify my path to add that directory, or I can move the script into a directory that is already in my path. And that's up to you. If this is a directory where you're going to put lots of scripts, it makes sense to modify path. Path is defined if you less your bashrc file in your home directory. You'll find path defined in there, and you can modify it. You can add directories to it. In this case, I just want to make it available where I already use scripts. So I'll move count FASTA into, I have some in my home directory, home, Jorvis, bin. And if I move the script in there, now if I just type count FASTA, since it's in path, it finds it and runs it. I no longer have to say in this current directory or give it any path. And of course it's not in this directory anymore because I moved it. So that's sort of the process of the write, save, run cycle. So write some code, save it, run it, and test it, see if it works, and then carry on after that if it didn't. Notice that my editor is still open, even though that file is no longer present. That's because the Emacs here is going off of what was in memory, and it doesn't know on the file system yet that I've changed it. It will if I start typing. But usually if it's edited, it lets you know. In this case, I can actually hit save again, and it writes a new copy. So just be aware of that your editor sometimes treats things differently if you move the file out from underneath it. But here I'll close, which is Control-XC, and then I'll remove this count FASTA because I've already made one in my home bin directory. Yep, so that's it. Hopefully this helps understand how scripts are read, how you run them from the command line, and the process of the cyclic nature of saving them to disk, testing them, writing again, saving to disk, testing. Thank you.